Hey guys, welcome back to AJ Tech. Today, today I'm gonna be live streaming an Arduino video. We're gonna go through an Arduino project where we connect an LED to the Arduino and do some basic Arduino programming, specifically with the Arduino Uno. So first, I want to show y'all the circuit that we're going to be using. It's going to be a basic circuit. We're going to have a voltage source, which will come from the Arduino. Specifically, it's going to be 5 volts because the Arduino outputs 5 volts. Next, there will be a resistor, which we're going to calculate soon, the resistance that we're going to need. And of course, the last thing we're going to have in the circuit is the LED. It's a basic circuit. Anyway, so the reason we have the resistor is because you have to maintain a specific current for a LED so it doesn't burn out. And for most LEDs, it's 20 milliamps. So if y'all have heard of Ohm's law, it tells you what's the resistance or current or voltage based on the other two variables being there. So since we know that the voltage of the Arduino right here will be 5 volts, and we know that we need the current through the LED to be 20 milliamps, we can use this equation through some algebra to find the ohms that we need, and then the resistance would just be the 5 volts divided by the 20 milliamps, or 0.02 amps, which will give us around 250 ohms. In reality, you can use anything within that range. So maybe from 200 up to 300, even 150 may be fine. We just want to protect the LED just in case it doesn't, so it doesn't burn out. All right. So now we're going to start out with this breadboard right here. And we will have this Arduino specifically. I have the law VIN. It doesn't matter what company because the Arduino board is an open source board, so it's okay no matter what type you have. So I was thinking I like to use specific pins, so maybe let me zoom in real quick. All right, so how about we use pin number 7? Oh, let me get the coloring correct. It doesn't matter, but it just helps for the red to be connected to the power. So we can connect this to pin number 7, connect this over here to one of those. So on a breadboard, how it works is that all these rows are connected, like they're all shorted together, all these rows, and then on the sides, these rows are all connected. So the minus, all these minus outside are connected, all these pluses are connected. So here, we're going to connect this pin number 7 to any row we want over here. All right. And then we were going to I specifically like the blue for ground. We're going to connect it to the ground pin. There's many, but I'm just going to use this pin right here. This ground pin. And we can connect it anywhere around here. Let's just make it closer so we can do it simply. All right. Then we can take the LED. Here's the red LED. And the LED is going to have one shorter leg and one longer leg, as you can see. The shorter leg is what connects to the ground, and the longer leg is what connects to the power source, which would be the 5 volts here. Let me get my resistor first, just so we can show you that too. So I have a resistor here, and this resistor is 200 ohms. So it's pretty close to the 250 that we calculated, but this is what I had on hand right now. We can test the resistance of this with a multimeter, or you can use the color coding that's on these things. It's not focusing right now. Yeah, if y'all can see, there's like a color code. And y'all can use that. There's like a chart to see like the first digit, second digit, and multiplier. But honestly, for me, I either have mine labeled, as I can show you here. I label my sets, or if something's not labeled, I use my multimeter, and I can show y'all that real quick. So here's my multimeter. We can put it into resistance mode, which is right here. So we can put it around the 2000 since we know it's going to be around that. Then what you do is you connect one side of the resistor to one side and the other side of the resistor to the other flip. And as you can see, it's around the 200 nominal resistance. It's of course not going to be perfect, but it's close enough. So we're good. In case we didn't know this. All right. So now let's connect this. Sometimes breadboards can be kind of hard to plug stuff into. So what I like to use are these pliers. They really help with connecting. Important thing, we connected somewhere along this like row that we connected to the 5 volts already. So then it's connected there. And then the other side will connect to the LED leg. We can just put it right here for now. So what will happen, the 5 volts will go through here into the resistor, and then we said the long leg connects to the voltage and the short leg connects to the ground, because LEDs are polarized components, so that does matter. It will not work the other way. All right, let me get this right here. Oops. Alright, they can get a little bit bent. I like to use the pliers. Alright, I think we have a good connection here. And the circuit should be done now. Alright. Now, since we've made the circuit, we need to connect the Arduino to the computer. Let me do that real quick. Let me check the chat. Okay, so now we can go into the code. Sorry for that. Wait, just fixing the chat. So let me go into the code. So this is the previous code I had. Let me delete this real quick. Okay. First of all, of course, we need to connect the Arduino to the computer. So let me do that real quick. Plug this in and plug this into the computer. All right, let's see. Let me go back to the code. All right. So okay, so what we're gonna do now to begin with, we can do other stuff later, but for now let's just make the LED turn on. So how we can do this, first of all, there's 2 parts in Arduino programming. There's the setup part and the loop like portion. The setup part, you kind of initialize stuff, like how do you want stuff to be and stuff like that. Like for example, the pin mode, if you'll have like specific variables, things like that. And then the loop part is actually what gets executed like every time. Like it keeps infinitely looping the code that you put in the loop. So for now, let's just write code that can turn on the LED. Let's just turn it on for now. So first, we need to specify that the pin that we're using, which we said was pin 7, as output. So what we do here is we have to write pin mode in the setup and write the pin number, which is 7. And since we want it as output, you write output. And then of course, don't forget the semicolon. So that just initializes pin 7 to be an output pin instead of like an input pin. Alright. Then in Arduino, on Arduino like IDE and everything, what you need to do to turn on the pin, aka set it up to 5 volts instead of 0 volts, is to use the digital write method. So you write digital write, and then you write the pin number, and then you write high if you want it to be on, aka like 5 volts, or you write the word low, all caps LOW, if you want it to be off. And we can try this real quick. Let me show y'all what the code while the Arduino looks like. Ooh, I need to fix this real quick. 1 second. Alright. So I can run the code real quick and let's see how it looks. We can turn this Arduino on. Alright, you compile first and then we upload. And as you can see, we have the LED turning on. And cool. By the way, like I said before, if y'all have any questions, let me know in the chat. So we could clear them up or anything like that. And as you can see, we have the LED turning on. Alright, so the next thing we can try to do would be to make code that can make this LED maybe turn on for 10 seconds, turn off for 10 seconds, and then turn back on for 10 seconds, and keep looping through turning on and off, something like that. So what we would do, we would have to introduce a method in the Arduino language called delay. And what the delay method does is it stops the code, or keeps the code as it is, pauses the code for the amount of time that you put in milliseconds. So let's say you put for 500 milliseconds, that would make the code pause pretty much for half a second. So if we're gonna want to have it stop for 10 seconds, we would have to have 10,000 here. And then what we were gonna have to do is then have it digital write low to make the pin go back to the off state. And then we would delay again for example, let's make it 2000, let's make it 2 seconds just so it doesn't take too much time. So let's make it turn off for 2 seconds and turn on for 2 seconds. And then what happens is once we reach the code right here, since this is like how the Arduino language works, is that we restart the code. So then once this is executed, it goes back to the top of the loop and keeps executing line by line. So what effectively happens is we have the voltage in the circuit at 5 volts, and then it waits 2 seconds in that state. Then it makes the voltage 0 volts, and then it waits 2 seconds in that state, and then it restarts back to on for 2 seconds, and we should keep looping through this. We can show this. Let me compile and run real quick. So what effectively happens is we have the voltage in the circuit at 5 volts in the circuit. All right, and I'm uploading. And then it waits 2 seconds and that makes the voltage 0. All right, and as you can see, we have the LED here turning on for 2 seconds, turning off for 2 seconds, and it will loop through this infinitely because that's like the way that the Arduino architecture works.